So, and also this sort method will work only when there is a elements of type one data type, right? So here our list is defined with the integer data type, and all of them are the integers, right? So you can sort only when all the objects are similar data type. If you go back to the previous programs, right, where it has the multiple data types, right, you cannot sort this. We don't know what is the sorting, right? Here there are few objects are numbers, few are the strings, few are the booleans, few are the double, so we cannot sort it, right? For example, if you try to put collections dot same thing here, collections dot sort of list one, right? If you try to run this program, it will give the runtime exception. It will not accept because this array list cannot be sorted because it contains the data of different data types. This is not right. Here now after sorting I print it here. Before sorting I print in the book. Since this is the first time of the day, so it takes some time to run the first day. Okay, it is completed. You see, this is the original list of which we have passed, that is 200, 100, 150, 250, 500 and 20. This is the sorted list. You see, from small number to big number, that is in the ascending order. In there is a method, yeah, reverse order. Or list dot, that's a different thing. Part of Java it will go that later. So this is all about the sorting. Let's write another example, GHI PSVM array list. Going forward, I will not be using any generic list. I will be always specifying the data type. Just for example, mostly integer I will use, but for your practice, you should try with all the other data types. Okay, list equal to new array list. List dot add up 100, list dot 200, list dot add up 800. So how do I iterate this? I just write the iter and then full space. Automatically I'll get this. See here, since our list is of type integer, we are getting the integer here, right? Earlier in our previous programs, we were getting the object, right? Because object is the common data type, right? That is a supermost data type. That's the reason we were getting object earlier. Now, since our list is of type integer, automatically we get integers here, right? Sort of integer, right? Here, each element of the list is becoming a integer here, or I would say number. I will put. Okay, I run this. It should print one by one. It has printed like this, right? Now, inside the for loop, we will try to add an element. List dot add of 250. This is very important thing. Please notice. I run it. I got the exception. What is that exception? Concurrent modification exception. See, the first element has been iterated, first element has been printed, and then after that I got the concurrent modification exception because the execution entered inside this for loop, the first number is printed, and then while trying to add this value, right, list dot add, we are getting the concurrent modification exception. Concurrent modification exception. This is called as a fail fast. Fail fast. What is fail fast? Right? That means whenever we try to do some operation, right? Whenever we try to do some operation, if it fails first, then it is called as a fail fast thing. The opposite of this is fail safe, right? So this scenario is the fail fast because the logic here is whenever you are running a loop on any collection object, that can be a list or any other types that we had seen in the last class, right? Like map set, hash map, reset, hash set, reset, right? So whatever it is, ArrayList, linked list, vector, right? So all of these are the collection classes, right? Whenever you are running inside the loop, you should not be you should not modify the collection. You should not modify the collection in the inside the for loop. Inside the for loop. You should not modify the collections inside the for loop. Either you do it before the for loop or after for loop. Or without for loop you can do it. It will work. It will accept to add the elements or remove the elements. Right? Not only this, right? So if I put list dot remove also. List dot remove also. Of the index, right? Even this also will fail. We'll get the same exception. Concurrent modification exception. See, concurrent modification exception. So this is the most important question in the interviews. They will ask like they will write a program like this, right? And then they'll write a for loop, and then they will try to add some method inside this, except printing it, either add or remove. Then they will ask what will happen. You need to tell concurrent modification exception because this is a fail fast operation. The reason is inside the for loop, you should not do any modifications to the list. Modifications are nothing but what? Just adding the elements or removing the elements, right? Adding the elements or removing the elements, right? So the modification is not allowed inside the list. If we do that, we will get the concurrent modification exception. So we should not do it. Okay. All right. This is one most important thing. Cool. So this is all about the array list. I mean, you can still do a lot of practice. You can try many other methods, right? And then you can try other flavors also with the different data types, right? So I'll move to the next one. What is that? If we go back to the notes, we learned about the array list. Let's look at the linked list, right? SVM linked list. So here also I specify the data type. Going forward, I specify the data types. New linked list. So here list dot add of 100, which is exactly same the way that we have seen for a list. Of list. Don't see any difference here. Okay. Can see all the methods list dot. If you put the dot, you can see all the methods and almost all the similar methods, right? Yeah. Methods add first, add last. I think we did not add these two methods in the array list class, right? If you want to add element in the first place, you can you can use this. If you want to add any element at the last place, you can use the add last. Get first, get last similarly, and then peak. Learn about the peak. Out of list. We should put it here. Dot peak. Set the peak gets the first element. Peak gets the first element. Similarly, there is another method pole. I think pole gets the last element. Pole also got the first element in it. Let's see what is the implementation. We don't use this very often. Retrieves but not remove the head of the list. That is the first element of the list, right? Similarly, let's look at the definition of the pole. Returns the head of the list only if this list is empty. First element retrieves and removes, right? Here see the difference, retrieves and removes, and the peak retrieves but not remove. Retrieves but not remove. I think since the difference peak. Now after pole, the same thing, you should not see that element in the list. See here, when we do the peak, we got the element and then I try to print, so no change in the list. When I do the poll, that means that removes the number. So 100 is removed from the list, so only 300 and 500 are remain. So that's the difference between peak and poll. We don't have to worry about all these functionalities, right? We don't use linked list at all, first of all, in real time. We use ArrayList is the most widely and commonly used one. Okay. Similarly, You can practice all the other methods on your own. All of them must be mostly are self-explanatory. If you get any doubt, you can just ask me, right? Or you can just click, just do it, and then hold control and then click on it. You can see the definition how it behaves. Okay, so let's not waste time here because this has a very least priority in list. But for the interview purpose, it is important to understand how it behaves. Similarly, the another thing we had is the what vector, right? Let's see how vector also works. G-H-I-J-K, vector of integer. Vector equal to new vector dot add of 10 vector dot add of 20 vector dot add of sort of row of 1. So element at the index 1 will be removed. Sort of vector. Program. Very similar behavior. You don't see any difference here. Now, right? You can see all the methods that are available in the vector also. Just put vector dot. You can see all the available methods here. Again, more or less it's a similar method. Adding, removing, containing, right? Last, first, remove it, remove all, right? All such methods. Again, my whole experience, I had never used this vector, so you don't have to worry. But it is just important to remember that vector also is part of list class here, right? All the methods, all the functionality, all the behavior is same. See, there are four different classes within the list. That is array list, linked list, vector, and stack. Okay, stack one I'm not even going to start. Okay, but why do we have three or four things, right? You might get that question. If everything is same, all the functionality is same, you might get the question saying that why do we have four, right? So that is because during the evolvement of this technology, right? So initially we did not have the array list. The very first starting data structure is we call all of them as the data structures. Okay, all of them are the data structures, right? So initially, somewhere maybe 30, 35, 40 years back, when they were just creating this Java language of the data structures, they just created the stack. That was the very oldest one. Later, they made some improvements, right? Then they had released vector. After some years, again they made some more improvements with some minor differences. They created the linked list. Finally, they have the array list, right? So all of them are more or less the behavior is same, but internally the way they perform, especially with respect to the performance, right? And also the memory consumption, because each and everything consumes some memory. Let's say, for example, stack is occupying 1 GB of memory in your laptop for holding an element. Array list will occupy in bytes. So byte is the very smallest number of the memory unit, right? So ArrayList is the most improved and fine-tuned and most performing data structure. That is the reason we have the ArrayList. So all others are old ones, right? Even for the ArrayList, just two programs before we had seen concurrent modification exception, right? We were getting the concurrent modification exception with the ArrayList. So to avoid the concurrent modification exception, there is one more array list has come, that is copy on write array list. Copy on write array list. This is also another list, but if you use this array list you will not get the concurrent modification exception when you use the for loop, right? So if you want you can see that example here. What I do is copy on write array list. Just name it like this, copy on write array list, new copy on write array list. And pass names and on write array list dot add of 100, copy on write array list dot add of 200, on write array list dot add of 300. Now I do the iteration iter and then enter. So by default, the latest collection object is the copy and write array. So it is of type integer. So everything is by default it has taken. If I try to dot add of, you should comment this out. So if I say copy and write array, now you will not get that exception. See, without any exception, it has run, and during the iteration also we could add the number 600 here. But it added three times because initially there were four numbers, right? So while running the loop, each time it is trying to add the 600 and it added all the times, right? 500 is coming from where I am not getting. Okay, this is the previous list. Okay. See here. So the list has 100, 200, 300, right? So each time it added 600. So that's the reason it had added 600 three times. But if you use the normal array list, it will not work. You will get the concurrent modification exception. That is the fail fast. This is the fail safe. Fail safe. So when they ask about this scenario, right? When they put the array list and then do the iteration and then try to add or remove elements, if you say that this is the fail fast, this will give the concurrent modification exception, then you will get the cross question how to avoid the concurrent modification exception. Then you should say that I will use the copy on write array list in place of the normal array list, because copy on write array list is the fail safe array list which is introduced in JDK 1.6. I don't remember exactly the version. I think 1.6. You can Google it out only, then get it, right? Likewise, all these classes are evolving, right? Even now the latest is copy on write array list. Even that is also like if it has been introduced in JDK 1.5 or 1.6, that means 15 years back. During this 15 years also they might have done some improvements, but they are not significant. That's the reason we don't have to learn about all those small improvements. If it is significant, yes, we need to learn about it, right? Likewise, each and everything else, though each and everything is same, there will be some difference in the performance or the memory management or the way that it behaves, but the purpose is same for everything. All right, guys, any questions? You can see, and also uh, the most important questions in this here are, now we have ArrayList, English, vectors, stack, and all these things, right? Difference between ArrayList and linked list. These are the important interview questions in interviews. Very important questions. The very first question, once they enter into the collections concept, array list versus linked list. For each question, there are some four or five differences will be there. You just need to by heart them. You don't have to worry about it. There are hardly five, six, right? For each thing, you just need to by heart it. So array list internally uses the dynamic array. Linked list internally uses the doubly linked list. And manipulation with the array list is slow because it internally uses an array. If any element is removed from the array, all the other elements are shifted in the memory. Manipulation with the linked list is faster than array list because it uses the doubly linked list. So no bit shifting is required. So all this terminology might be bit difficult for you when you read it for the first time, but over the period of time, after reading multiple times, right, after seeing multiple programs, when you soak into the this technology, right, each and everything is very easy to understand. So you don't have to worry about it. For the first time, go ahead and then by heart it. No worries. Okay. Go ahead and then by heart it. So you can see the difference between array list and linked list. Similarly, you should see the difference between array list and vector. Right. See, array list and vector. These are just only for the interview purpose. But in real time, we use ArrayList. Out of all these four classes, five classes, 99.99% of the times we use the ArrayList. ArrayList and vector, the differences. ArrayList is not synchronized, vector is the synchronized. ArrayList increments 50% of the current array size, and vector increments 100%, means double the size. So all these differences are hardly 4 or 5 points. You just go ahead and then by heart it. Only for the interview purpose. And these are not useful anywhere. But in the interview, these are the most important questions. Alright guys, this is all about the list type. We go to the set in our next class, right? So we learn about the set in the next class. Meanwhile, you do the enough practice on this list thing. Cool. If you have any questions, you can ask me now. And if no questions, we'll stop.